Hi, everyone. Today, we will do some analysis using Pandas library. But first, you need to go and download the materials. You can get it from my GitHub page. The link should be on chat. I will also put it again here quickly. And you need to have a Jupyter Notebook program. If you don't have it on your computer, you can install using Anaconda, which there should be link on Meetup page. So let me just share it again to you. But it takes time to install this Anaconda. I hope you already have Jupyter Notebook on your computer. You probably have. Okay, you can get this Anaconda program. Inside this Anaconda program, we'll be using Jupyter Notebook program. Okay, there are two things that you need to do. First, you should have this Anaconda installed on your computer. The next thing is to have these materials getting downloaded from your from my GitHub page. So I guess you have some sort of Python experience, and I will try to explain this as detailed as possible. Some part might be boring who are advanced in these topics. Some parts might be overwhelming who do not have much experience in this. So I hope you enjoy this, first of all. Okay, please go and download this workshop material from GitHub. And then if you haven't installed this Anaconda program, please do install it. There are different Python IDEs. Some people use PyCharm or Visual Studio. I will first give a brief introduction about Jupyter Notebook because some of you may not have seen it. So once you install this Anaconda, there is this Anaconda Navigator. So you can just launch it. It's a nice platform, by the way. So there are different programs available here. We'll be using just Jupyter Notebook here. Okay. Please launch this. You can get the link for the GitHub on the chat. Please download the materials from there. So when you install Anaconda, you should have seen this Anaconda Navigator. Then you can launch Jupyter Notebook here. Or from your computer search menu, you can just type Jupyter Notebook. It should appear. And we'll be using just one part of the repository. So yeah, you can clone the entire repo Marcin, I guess. So from the Anaconda Navigator, just launch Jupyter Notebook. And you can ask your questions in Q&A section. I will try to keep up with that. I will try to answer questions. So I just wait a bit so that everyone can download the material and launch this. So here on GitHub for this, so let me open. So on GitHub, we'll be using GDB per capita. Okay, we'll have this. You can just download this GDB per capita. There's also another example here. If you want to do some practice by yourself later, you can use this example as well. But today we'll be seeing this GDP per capita example. So just download the material, and I hope you already have this Anaconda or a Jupyter Notebook program. Let me show it again. Once you install this Anaconda, there should be this Anaconda Navigator on your computer. So once you launch this Anaconda Navigator, there are lots of programs are available here. Then you need to launch this Jupyter Notebook here. So on GitHub, we'll be going through this GDP per capita example. So once you launch Jupyter Notebook, once you click on Anaconda Navigator, it should open on your browser. Okay. So I'm just explaining this for the people who do not have experience on Jupyter Notebook program, because there are other Python IDEs that people use. So some people do not have experience on this program. So Jupyter Notebook just launches on an internet browser. So whatever your default browser, it will open it. So mine is Firefox, and it opens on this Firefox. So one, it opens. So here, so these are my folders. Okay. Then I need to go through this folder to find. So for example, just check where you download these files. For example, I downloaded this file on my desktop. Okay. I can go there, open it from desktop. Okay. So or if you download this to your download section on your computer, you should just go there. So you can browse, or you can just navigate through your folders here by just clicking on it simply. Okay, this is my main directory. So these are the folders under my main directory. Then I will just navigate through other folders here. As I said earlier, I just downloaded this to my desktop. If I just click desktop, now these are folders on my desktop. And here, so here, Pandas Workshop Master. Okay, if I just click it, so I just simply download everything on my GitHub there from the link that I provided to you. Again, if I just click on it, it will take this one. So this IPYNB is a special extension for Jupyter Notebook. And there are two files, the problems and solutions. Let's open these problems. So I will just give you, I'll just let you do some part of this task. And if you cannot keep up with this, the pace, then you can get it from the solutions. Okay, so we'll go through these problems. So some part of the comments will be, so here it will be done by you. If you cannot do this, or if you just, if you are behind, then you can just come and copy it from solutions. So we'll just open this. Okay. So as you see, the commands are not complete, so you are supposed to complete this. So we will do it together. So before starting, let me show you how this Jupyter Notebook works. It's quite easy. In fact, it works as cell basis. So we have cells, and we just go there, write our commands in the cells, then we just run those cells. So this file I created, from scratch. For example, if you want to create a new Jupyter Notebook from scratch, so you can just come here and say this. Okay, this is just to show you, for example, if you want to work later, starting from an empty notebook, then you can just do this. Let me show it again. So there is this new, if you just click Python 3, then an empty file should appear here. But so let's go here. We need to just create cells here. The easiest way of doing this is this. So there is this plus. Okay, if you just click, an empty cell should be created here. So what is important for us is the mode of this cell, which you can see it here. So it says code, so it expects from us to put some Python command here, like I did it here. Just a quick example, we just say print hello here. So I just type this. The next thing that I should do is to run this cell. Okay, I will just go and just run it. Okay, so you just simply create a cell. You should mind the mode of cell. So right now, we just put Python command here. But for example, you may just put some comment here, or you may take some notes during this workshop. Let me show you how you can do this. For example, I just typed this before as comment. So let's create a new cell. So now I will switch this code from code to markdown. Okay, then you can just write whatever you want. So as a comment here. I should also run this again. Or the shortcut is Shift and Enter, I think. Shift and Enter buttons here, or keys. So you just press Shift, Enter together. It should run this. Okay, I hope you are following. Let me just again start over. You need to go and download this Pandas workshop. And you should have a Jupyter notebook. If you have Anaconda, you can just simply go there, click launch, then it will appear here. There is one thing that you should be careful about. I think from GitHub, it downloads a zip file. Maybe it depends on the computer. Yes. You cannot open a zip file from here. Okay, from GitHub, it downloads as a zip file, at least on my computer. So I don't know the other computers, but on my computer, it downloads a zip file. So you should unzip this file, then open it through Jupyter Notebook. Okay, for example, again, I cannot open this. First, I should go there, unzip it. Then I can just come here. So we have this GDP per capita. Again, we'll be going over these problems. So as I said earlier, there's also solutions here, which contains the full comments, okay? So we have this GDP per capita data that I took from World Bank, though I hadn't updated this file. Sorry, it's a bit outdated, but nonetheless, it should work. So Pandas is a very popular Python library. If you have a table-like data set. I mean, it could be Excel file, or it could be some table that you obtain from a database, or if it's something like CSV file that we'll be working today. So we can process these files or data using Pandas. The first thing that we should do is to read data from this source. Okay, source in this case is a CSV file, but as I said, it could be an Excel file, or it could be a database, or it could be just link that you go and fetch data from it. So it doesn't matter. First, we need to just read data from this source. But before that, we should just import Pandas library. So Pandas has lots of read function that allows us to read data from different sources. And if you want to read the data from a CSV file, you can use this read CSV. Okay. And you can look up the documentation of a function here. Okay. Once you put your pointer somewhere on the function, if you press Shift and Tab together, Shift and Tab together, then you can see the options of this function. This is a very comprehensive function because the CSV files that we take might have different forms. And thanks to Pandas developer, they just put lots of options to cover all different cases. Okay. But anyway, the most important option is to file name or file path, let's say. So you should just write the path of the file. So the file that we'll be reading is in the same directory. Okay, so in this case, it is okay just to write the name of the file. Okay, so since I put this CSV file in the same folder, we can just simply write the name. Okay, I got an error. So if you get an error, we should just look at the bottom of this page. It says, okay, it is not explanatory. Sometimes it is quite explanatory. Parse error means not what it tries to get data as columns, right? It will try to separate columns. And in CSV file, another most important option is separator, which is by default a comma here. So let's look at our data. So what is the issue with our file? Sometimes, even though it says CSV file, the separator might not be a comma. Okay, this might be a case. Yes, thanks, Edward and Geoffrey. Yeah, sometimes the separator might be different. Okay, so do not trust if it says CSV. It might not be always a comma, so semicolons could be used. So here the problem here is this: the first 4 lines here. So normally Pandas just assume the data or the column names start right away. Okay, but sometimes, as you see here, people put some explanation to the CSV files. So you can just simply delete this, or we have an option for that as well. We have this skip rows option. This allows us to just omit certain lines. So here it is 4 lines. If I just say 4, it works. So let me just quickly take a look at this. Okay, just put skip rows because if you look at here, there is some explanation probably. I mean, when I download it from database, so it will just written here. It's written here automatically. So, so we just read the data. So when you work with Python, one of the most important thing that you should be careful about is the type of the data that you are dealing with. So if you know standard Python or basic Python, you have data structures like lists, dictionary, set, tuple, right? Strings, and integer or floats. So these are the basic data structures on Python. So here, when we work with this Pandas library, there are 2 really important data structures, series and data frame. Of course, this whole library is not limited with these 2 data structure, but these are the most important ones. So anyway, once we launch this command, it just return us data frame object. Okay, I just simply call data here, though most people prefer df as data frame. Okay, anyways, I just simply say data here. Okay, let's summarize. So what we did so far, so we just simply read data from the source and we created a data frame. So if you are working on Pandas library, you should definitely create this data frame. And thanks to this read functions, so you can really read data from a variety of sources. So we can just simply look up here. If you just write pd.read, and if you press tab, pd.read, if you just write this and press tab, you can see from what sort of data sources you can read it. I think it's really good. So it covers lots of things. So the clipboard is also very convenient to use. Let's say if you work on an Excel file, if you want to take, let's say, a part of the Excel file, so you just simply copy there and paste it here, then it will create a data frame to you. I hope you are not falling behind. So I just try to Akshay says, instead of using skip rows, can we use encoding Unicode escape? I don't know the answer, but encoding is different than the other one. Let us try. I also wonder. So instead of using this, nope, that's something different. The encoding is something different. But I admit, if there is a smart way of just skipping the lines, I didn't dig enough to find that option. If there is, I mean, now we can see in the first 4 lines, if we had many lines on the top of the page, I mean, you should just scroll it down. I don't know if there is an automatic way of just, skipping this maybe non-column wise rows. So anyway, so we just read data. Okay, we just created our data frame. So let's go over this. To create a new cell, you can use the shortcut is B or A. For example, if you want to create something below, you just press B. Okay. If you want to create something above, you can just press A on your keyboard. So, and if you want to delete something, you just press double twice on D. So it will just simply delete. Yes, Haider. Yeah, that's also another option. Haider Ali says you you can just delete it. So both works. Okay, so we have our table. Okay, data frame is a table in Pandas. This data.head function just displays the first 5 rows. It's like a preview of our table. Yeah, I do this always because when I create data frame, I want to know how it looks like. So if you just put data head, it will display the first 5 rows. So we have the GDP per capita for the countries through the years. Right, that's what we have here. It seems the latest data we have is until 2019. So there are some data numbers because apparently data is missing for some country for some years. For example, look at the arrow bar. So you see there's nothing here. So that's why these are not a number. So we have country name, we have country code. So indicator name, that is GPT per capita, because if you download data from World Bank, there are different indicators that you can see. So that's what we have. This is not important. What's important for us, the data that starts from here. For example, the Afghanistan's GDP per capita in 1960. This should be, okay, that's in dollars. Okay. So let's maybe look at the current. Angola has maybe $2,000. So Afghanistan has $500. Okay. So let's do a small, let's say, transformation. So the country name now is on a column here. So let's set this country name as our index, because that will be convenient to use it later on. Okay, we want to just move this country name information to the index of this table. And we can do that using set index function. In fact, we might need this operation sometime. You know, sometime you look at your table, you say, okay, if I put this information from column to, let's say, row index, it will be better, or it will be easier for me to work with it. So you can do that using dataset index. And you just simply write the column name. I will just simply copy this. Oh. Where am I? Yeah. And there is also one of the very important option in Pandas is this in place option. This is really important. Let me show you first without doing this. Okay, I said data set index country name. Now, as you can see, now indices become country names. But if I go there and check this data frame again, okay, now the country name is on a column, right? It is not on the index, right? So though we just saw from the output here, so output just correctly puts country name to the index, but if you check it again, because if you just press this again, you see that it is not on index. So the reason for this is this in place option. You'll see this option in maybe most of the pandas functions. So what this says, in place false, what it means, it will make this change not on the original data frame. So it just simply takes a copy of our data frame and it does this operation on copied file, not file, copied data, let's say. So it will just keep the original data frame. It will not touch it or it will not change it. It will create a copy of it and it will do the change on the copy. Okay, that's what it says, in place false. I don't mind changing the original data here. That's why I will just say in place true. Okay, so again, this is a really important option. And the default option is most of the time is in place false. Maybe all the time because I don't know all the functions, but most of the time it says in place false. What it means, it will not make the change on the original data. It will create the copy of the original data. It will do the operation on the copy or copied data. But here, again, as I said, I don't mind changing the original data frame. So that's why I say in place true. So right now, if I check this, now you see it is on the country name now is on the index. Again, if you fall behind, please go and open these solutions. You can just copy it from there. So the next thing is to delete a column or more than one column. As I said earlier, so we do not need indicator code, name, and country code. So let's delete these 3 columns. Okay. There is more than one way of doing this, but I will be using here drop option. So this just simply allows us to delete some columns. And the way of columns, so we have columns here. You will just say columns. And you need to put a list here and just simply type the column names that you want to delete. So I will just simply, maybe if I just copy. So I just simply copied column names there. And again, we have to check if there is an in place option. Yes. Right. So then I should say in place true. I just wait a bit. So data drop allows us to drop some columns, and we'll be using this columns option. And you just put a list here. You just put simply type the column names that you want to get rid of. And we do not forget putting in place true option here. I don't know, it is nicer with this way. So we can just see country and right away GDP data or GDP per capita data starts from 1960. And again, the head just displays the first 5 rows. It's like a preview of our table. I hope you are done with this part. Okay, let's play with this data. Let's say I want to get data for Italy. Okay, what it means, I need to go this table, find the row for Italy. Okay. So we are doing this using log function. So if you want to access data using row index or column index, you should be using this LOC log, this function. This allows us to retrieve data using column index or row index. In this case, I'll be using row index, which is Italy here. And one important thing, if I say Italy here, I will probably get some key errors. Yeah, I got the key error. Because as you see, it starts with capital I, the letter starts with capital form. So that's why I should be using capital I here. It's a bit of working with Python, so you have to be careful about these cases. Okay, log Italy. Now we got this, the row that stands for or correspond to Italy index. Okay, what did we get here? So as I said earlier, so there are two important data object here in Pandas. The first one is data frame, the other one is series object. So you can think of series as one column of a data frame or one row of a data frame. So like this, so we just fetched a row of our data frame, then Pandas returns a series object. Okay. Or if you got one column of a data frame, then you would have gotten again a series object. Okay, the question that we have a question, can we compare log and ilog? What are differences? So as I said, so log allows us to get data by row index or index. So ilog is used for position. For example, if I want to get the first row of my table, then I should be using ilog. So if you want to retrieve data by position, then you should be using ilog. Again, maybe 10th row, I want to get 10th row, then I will be using ilog. Or if I want to get row that correspond to Italy by index, I will just fetch data by index. In that case, I'll be using log. So it just goes there, tries to find Italy, and it just gets me data. But ilog will just simply get data by position. So here, for example, now we just get data for Aruba. Yeah, so we have a series object. Let's look at what it looks like. Okay, Geoffrey, you got a key error. So either you just use lower letter I here, or just make sure that the country name is on the index. You can just simply data head again. Okay, so you should be seeing this country name on the index, because if you didn't type this part, if the country name is on the column, then you will get a key error because it will not find Italy text from the index. Okay, just make sure that the index is as we want. It's like country name. So we have GDP per capita for Italy. In 1960, they had $800 per capita. In 2019, they have $33,000. Okay. What else? If you just use tail, that will display bottom of this table, column, whatever it is. Okay, head will just simply display the first 5 rows, and tail will just simply display the bottom 5. So what is the task? Find the year that Italy has the highest increase of GDP per capita. Okay, first, we need to calculate yearly percentage increase compared to previous year. Okay, we'll just simply, how much increase or decrease, let's say, not increase, let's say percentage change, let's say that will be better, I think. Percentage change, we'll just compare this year data with the previous year. And we have a nice function in Pandas to do that. So here, if you go there, there is this percentage change. Okay, this is exactly what we need. A percentage change. And what is it? It is these ones. For example, I take these numbers, 1961. I subtract it from these numbers, and I divide this by this. Okay, this is what it will return to us. So I will just do it manually for one, but percentage change function will do it for us. So right now we just simply calculated percentage change for Italy, yearly percentage change. So then we see not a number. So why do we have not a number? Any idea? So why do we see not a number here? Percentage change. Yep, Geoffrey. Exactly. So there's no previous value, right? So we just simply compare values with the previous value, right? So we don't have any data before 1960. So that's why it returns not a number to us, right? Simply you just compare one. It's like I just compared this with this. Right, so that's why it returns not a numbers. And okay, this is this one that we get it. So we just simply calculated percentage change, yearly change. And if you want to multiply this by 100, let's do it. Because I want to say, let's say 10% change or 11% increase or maybe 3% decrease, whatever it is. So let's multiply this by 100. So these sort of operations are quite easy on Pandas. For example, if I gave this data as a Python list, and if I ask you to just multiply this by 100, then you need to just go there, make a for loop, right? So it's a bit long way of doing this. But so here you can just easily do this. If you just use star and put 100, you will just multiply all the values in this series by 100 here. So if you have some experience with basic Python, typically people just try to learn, let's say, making for loops in basic Python. But when you just switch to these libraries, so we just encourage people not to use for loops because it's a bit slower, maybe not a bit, maybe quite slower than what the Pandas is doing for us. Okay, so we just multiplied this. But again, if I go and check how my Italy percentage looks like. It hasn't been updated. So to do so, you should be doing this. You just simply update value of this variable. Okay, this will just create this data, and you will just simply assign this output to this variable. Okay. So right now we have, percentage change of Italy. Now we want to find the year that Italy has the highest change. Let's say highest increase, because highest change could be, it could be also -30. Let's say you have -30, right? Maybe in 1 year, their GDP per capita decreased 30%. Maybe in another year, they have maybe 20% increase. Let's talk about as increase, okay? It's not highest change. I think Magnimind people will share the material, or it's uploaded, I think, at some time to their YouTube website. So now we have our values. By the way, let me show something. So we have our data, but Jupyter Notebook does not display all the values here. It only displays first 5 and the next 5. This can be a bit annoying. If you want to display everything, you should do this. So there is an option here. Display option, maximum rows. So by default, let's say if you have a table of 50 rows, okay, it will display everything there. But if you have a table of 60 rows, maybe 70 rows, it will not display everything. It will only display first 5 and last 5. Why it's like this? Imagine if you have, let's say, a table of maybe 10 million rows. If you display all 10 million here, unfortunately, this Jupyter Notebook becomes really slow. If you have many lines, if you just try to display everything here, the Jupyter Notebook performance is really poor. That's why it just simply displays first 5 and last 5. But let me just show it again to you. I guess 65. So we were just 1 away from 60. So anyway, let me do this 61. I put this threshold as 61. Now I am able to see all the values in this here. So, we can see this. Basically, what I want to see, I want to get the year that Italy has the highest increase, let's say. It is this one. I think it's that one. But we have to do this by code. So we have 60 lines, so we can do it here. But if we had many lines, we wouldn't be able to do this. So there are different ways of doing this, but there is really nice function here. But before, let me show you this one. First, you can just take a look at the max one. And again, that is the advantage of using this tool. Pandas, it offers functions that are often used in the data analysis, right? So we have this max, it will just simply the maximum increase, right? But what I want to know is the index, right? Not the 4 to 1. I want to see the year that we see this increase, right? So then we have this IDX max function. It's a really nice function. So IDX max, so it will get us the index of the maximum value. The index of maximum value. So then we can say that the maximum increase is 1960, sorry, 86. But there's also IDX minimum, so you want to get the IDX minimum. Yeah, let's see when it is. When was the highest decrease in Italy? In 1993. Okay. So what is the other question? Find the years that GDP per capita decreased compared to previous years. Okay, basically, we want to get the years that we see decrease. It's like 1976, 1981. But we want to just simply get the years that we see negative values here. Okay, there's a question. What happens if there is a tie for maximum and minimum value? It's a really good question, Ross. It will only display, I think, the first one that is. It's a good question because it might not display all the values. Right. So let me check if there's an option here, which is probably not. Oh, it just displays. You see in this example, so they have 4 and 4. When I say IDX max, it only displays C. That means you need to write more code if you want to put this action. Then you need to go there and check. So once you get your maximum, if we can simply do this trick. For example, you can say I mean, this is a bit longer version, but so if you do this, then you will get whatever. I mean, if there are 3 numbers, I mean, 3 indices sharing the same value, then you will be seeing this with this version. But with IDX max, yep, it's a bit. Anyway, just it's one scenario that we should keep in this mind. I mean, it's not, if it's something like integer, then that might be the case, but the floating point numbers, not much likely. So anyway, let's come back here. So we want to find the years that we see negative value. So this is our series here. So we need to find the years less than 0. So we just simply make a simple comparison here. So we just compare this series, whether if it is less than 0 or not. So what does it do? It will just go there and check all the values if they are zeros or not. So for example, it says false. That means the data for 1960 is not less than 0. For example, here, 1976, it says true. That means we have a decrease in this year. And we just made a comparison. it just went through all the data there and then return us true or false. So, so what I will explain is called Boolean indexing, which is very important in Pandas. We'll be using this truth as the index. It's like this. So the square bracket is for indexing. In Python, if you just put square bracket after a variable name, then you will be indexing. So here as an index, we just put true and falses. In this case, Pandas will retrieve us the rows that we see true here. For example, we will get 9076, we will get 9081, 9082, and so on. Okay, you put your variable name, and square bracket is for indexing, and as the index, we just put this expression which returns what you see here. Then as a final answer, it will just return us the rows where we see true. Okay, for example. So basically now we see all the years that the GDP per capita decreased. So let me ask how to get this drop down in the Jupyter to visible code. Which drop down mention RAM? I couldn't catch this drop down question you asked. Okay, so we got this our data, but let's say if you want to get the years, not this table, then you should be using dot index. Okay, let me just show this. So these are indices, these are values. Sometimes we are interested in indices. If you put dot index, you will get index. Or sometimes you are interested with the values because the series has it both. It has both indices and the values. Sometimes you want to get indices or you want to get values. And you can just simply type index or values. So anyway, here, let's say I'm just interested in the years. I don't want to see what numbers we have for a specific year. Then I can just simply put index. So it will just return us the years that the GDP per capita decreased in Italy. Okay, I think I can just put it here. Okay. HKSA, does it print just unique values? Nope, it doesn't have to be unique. But in this table, it is unique, but it doesn't have to be unique values here. Okay, what else? Let's go up here. Find the year that the GDP per capita of the world increased the most compared to previous. So we'll do the same thing, but as a word, there should be one line that corresponds to word. Okay, so in one line, I think we should see something like world. So then you will get GDP per capita for the whole world here. So let's try to get it. So I will just leave it to you first, and I will do it by myself. So in the previous case, we just got data for Italy. Now you will get data for world. As I said, there is one row the index is world. So you need to then fetch that row, and you can use log function here. And you need to just type world there. We can also look what country names we have. So let's do this. Data index. It will get me the index. And if you just type unique, it will display all these unique names. Okay, this is annoying. You know, this the 3 dot means it's like, you know, it doesn't show everything here. I wish it did. So we can access the data, but it simply does not show everything here. Anyway, there should be some rows, the world written there. Yeah, from Delandra, it's a good question. Is there any shared location for all the data and notebooks? Yep, I don't know. Maybe Magnimind people know it. Chetan asks, is there any open source library framework to do this on a real-time data? Yeah, real-time is a completely different thing, Chetan, which I don't have much experience there, I will say. Okay, thanks, Edward. So if you just convert this to list. Yep, sorry. Thanks. No, because on a Python list, we are able to see what we have here. You see, there's just one row that we have world. So let's do this. I want to access data for world. And again, if I just write not correct, I will get key errors. So you have to be careful here, which might be a bit annoying, because sometimes there might be spaces, and not in this data set, but I have encountered this issue. For example, if there is written word plus 1 space character there, then if you just type word like this, it will not match. Just careful about it. So now we get data for the whole word, GDP per capita for the whole word here. Now we will do the same. Just try to find the year that has the highest increase as a world. So you will do the same. First, you will calculate percentage change. Then you will get the maximum index of the percent change, like you will apply IDX max there. I just wait for you to do this. So first we need to calculate percentage change. So before this, I want to plot this. I just wondered, how does it look like? So there's this plot function. It will just simply plot GDP per capita of the whole world to the years. Okay. So first we need to calculate percentage change. Oops. So now we can see the increase here or decrease. And the next thing is this. By the way, you can apply these functions as a chain. For example, in the above example, I just, first created this, then assigned it to variable, then I just, on the new variable, I just applied new function, but you don't have to do this. You can just simply apply a series of functions here. For example, now I just calculated percentage change. Now I will just simply apply IDEX max afterwards. Okay, IDEX max. Okay, this is our answer. As a world, we have the highest GDP per capita in 1973. Okay, what else? So find the top 10 years that have the highest standard deviation. So we will calculate standard deviation for each year first. That's what we have here. For basically, we will calculate standard deviation of each column. We have this STD function, which allows us to calculate standard deviation. And by default, it calculates standard deviation of columns. So if you just simply apply this, by default, it will calculate standard deviation of each column. Okay, now we have standard deviation for each column. The next thing is to get top 10 years that has the high standard deviation. I think the easiest way of doing this is there's a nice function called n largest. You just simply put top n, let's say I want to get top 10. It will just simply display, it will just sort this data and it will just display top 10 here. We also have n smallest. Okay, it's a really nice function, is n largest and n smallest. Another approach will be just sorting this data, then getting the first 10 elements. Okay, you can just go there and sort it. And after sorting, you can get maybe the first elements. That's also another option here, but this is better. It will just display top 10 here. And if I want to get the years, not the values, so I will just simply put index here. These are the top 10 years that we have the high standard deviation. Okay, let's do this. So which country has the highest GDP per capita in 2019? First, we need to get data for 2019. What it means, we need to get a column of a data frame. So we need to access this column. So you can access a column of a data frame using square bracket. So remember, before we saw log function, log allows us to access both column index and row index. But typically, we need to access, or we do access columns. And the easiest way of doing this, data frame, then square bracket, and the column name. Okay, what might be the issue here? Any idea? So why did I get an error here? Okay, thanks. There are a couple of answers. So we need to use codes here. So you have to be careful when you're dealing with this case like this. So, I mean, it looks like an integer, but apparently it is not an integer. So you have to use quotes here. Okay. And you can just simply see this. If you just type data index, data columns, you see, then you see, okay, Python stores this information as string. If you see object, you can think of it as a string. Just be careful, because sometimes it may be integer. So anyway, we just access the data for 2019 here. Okay, these are data here. So let's try to get the country name that has the highest GDP per capita here. In fact, we can also use now index max here, right? Because what we want is the index of the maximum number here. So we have 264 numbers here, and we want to get the index of the maximum numbers. So then again, index max is really good here. It's Luxembourg. So Luxembourg is the richest country. Can I say richest? May not be, because there's a different indicator, right? So, but they have the highest GDP per capita in 2019. If I say get me top 5, okay, highest GDP per capita, whatever it is. Then index is not working here. Okay, this works just for the top. I wish we had an option like, top 5. But we do not have. Then you can use n largest here. So IDX max is work only for the top element. If you want to get the top 5 countries, then you should be using n largest here. So let's see which countries has the highest GDP per capita in 2019. Okay, these are the top 5 countries in 2019. Okay, thanks, Edward. If you just plot this, does it plot a bar plot, or if we can also do this, let's see. So you can just simply draw as a bar plot. It's not bad. Okay, as a last exercise, let's try to get the rank of Luxembourg. So we'll get the rank of Luxembourg as a year. For example, right now we saw that Luxembourg is the top country in 2019. I just wondered, the performance of Luxembourg in other years. So there's this rank function. So the rank will calculate rank of each country. It's a very nice function, but there is an option here. We should be using ascending false. right? Because if I say ascending through, the lowest one will be ranked first. Okay, so here, if I say ascending falls, the highest one will be ranked first here. So for example, what it means, Afghanistan is ranked 128th in 1960. In 2019, they are ranked in 217th. Okay. For example, Andorra is ranked 27th in 2019. So we'll get the rank of each country, basically to just show the rank in each column. For example, Zimbabwe is ranked 183. By the way, here, the tie is important. Okay, David, you are right. Should you not remove the word from the... Yeah, we should have done that. No, there's also one row for word, right? Anyway, you can do that. So you can do that using data drop option. So I was talking about the if we have the same number, if there's a tie, then the rank is a bit, I would say, different. You should be a bit careful about it. But I do not guess that we have a tie here. So now we have rank of each country through the years. Let's get data for Luxembourg. Okay, you can just go there and fetch data. Again, I want to get a row for Luxembourg index. That's why I am using log function. For example, if I want to get data for Andorra, I will just use log and put Andorra in it. So here we just simply say Luxembourg. Now we get the rank of Luxembourg, and I think it will be better just to plot this to see how it looks like. Wow. I think they're really doing great on the last decades, I think. Right. So there are some up and downs here. I don't know why. So for example, around 80s, they were ranked as 14th, something like this, right? They were below 410. So after 18s, they're doing really great, I think. So we can we say they are in top 5? So let me do this. So I will be using now another library, which is matplotlib library. Matplotlib library, pyplot. I just wonder, I would just draw a vertical line, not horizontal line. 4, 5. Okay, I think okay, this is a bit playing with the visualization. I just wanted to draw a line for the 5th position. Yeah, they are even better than those. If I say 4, yep. So after 1990, so they are in top 4, we can say. It's quite good for them, I think. So here, so we just used a function for matplotlib library. By the way, Pandas is also using in the backend, it is also using matplotlib library. But you can just combine this. And also, if you want to get the years, for example, I want to know in what years Luxembourg ranked top. So I think it is this. Maybe this. But we have to get it right. So what we can do. So now we can access the rank of Luxembourg. I want to see when their top, right, rank should be 1 here. So if the rank is 1, then you'll see true here. If you see false, that means rank is not 1. And as I showed you earlier, we can use this as index. This is a very standard operation in Pandas. Okay, that means it was only 2019 that they were ranked as top here. Okay, that means it is 2, right? Second, they're second here. So that's all for my workshop. If there is any question, I can try to answer your questions. So as I said, there's another practice that you can try by yourself. So there's some data from COVID-19. So you have problems and solutions. You can try to do it by yourself problems. If you have any difficulty, you can just try to cheat from the solutions here. Okay, there's a question from Geoffrey. Is it possible to fill a missing value halfway between the previous next value? I mean, we have this fill NA, but it will just replace everything. Halfway between the previous and next value. So you can use, I mean, there are functions like this. This is forward fill. So it will put a number before not a number. Okay, the forward fill. Let me check it if there is not a number here. We don't have a not a number. So we had not a number for, let's say, this Kosovo. Let me say this is X. We have data rank. So we have not a numbers here. So there are this forward fill or backward fill. So here, just simply used 158 for, so just fill backward from this number to there. Need to do time series on a country through the years. Missing years will be an issue. Yes, you're right. Missing years. You can do this, or sometimes you can do interpolation. That's also quite useful. So you have interpolate. It will just simply interpolate. If, let's say, you have data there, you have data there, but you don't have a data here, then it can interpolate there. It is also a nice option. Any questions for your side? Yeah, from the audience, I think they're really diverse backgrounds. People who are currently using Pandas, people who are not currently using Pandas but have some Python experience, people who don't have any Python experience. So I think for those who do not have any Python experience, then this is really overwhelming because we directly jump into the library. Because before this, you should have at least the basics in Python, how method works or how we can launch, method, etc. But I think it's a good practice for you to see, how you can use this library. And the other data set, for example, this is for time series. If you have time related data, for example, we have, let's say, daily cases for countries. So is a good example for a time series that you can look up this later. Okay, so we don't have any further question. Okay, I hope you enjoyed this workshop. Okay, and have a nice day or evening, depending on where you are in the world. Okay, bye. Take care.